If you had a time machine, you'd need to pack carefully. Depending on when you land, you might visit a planet completely covered in ice or a planet with palm trees growing at the North Pole. Our Earth has toggled periodically between being a hothouse and an icehouse. But what causes this change? Let's find out in this video. Earth effectively has two operating modes. Mode 1 is hothouse Earth, also known as the greenhouse Earth. This is a period when global temperatures are much warmer, and there is no permanent ice anywhere on the planet, even at the poles. Sea levels are much higher. Tropical climates expand toward the poles. Carbon dioxide levels are high. The hothouse state is Earth's normal setting. It has been like this for 85% of history. The age of the dinosaurs was a classic hothouse state with warm forests near the poles. Mode 2 is Icehouse Earth. It is characterized by ice at the poles, lower sea levels, and a major temperature difference between the equator and the Arctic. An Icehouse Earth is a period when the planet is cool enough for large, permanent ice sheets to exist at the poles. During the Icehouse state, we experience cycles of glacial periods, when ice expands, and interglacial periods, when ice retreats. But overall, the planet remains relatively cool. Lower global temperatures, lower sea levels, and relatively lower carbon dioxide levels. Right now, we are living in an Icehouse Earth, specifically in an interglacial period called the Holocene. Earth's climate has flipped between extreme heat and deep freeze many times in its history. But why does it toggle back and forth? The biggest reason is carbon dioxide. When volcanoes release large amounts of carbon dioxide, more heat gets trapped in the Earth's atmosphere. This creates a super greenhouse effect. The planet warms, ice melts, the oceans rise, and we enter a hothouse state. So, how does the Earth cool down? The Earth cools when the amount of carbon dioxide in the atmosphere decreases. When continents collide and form giant mountain ranges, like the Himalayas, it pushes up billions of tons of fresh silicate rock. The carbon dioxide in the atmosphere dissolves in rainwater, and when this rain hits the silicate rocks, a chemical reaction happens. The rock absorbs the carbon dioxide from the rain. The carbon gets trapped in the minerals, washes down rivers, and eventually settles on the ocean floor as limestone. As carbon levels drop, the temperature plummets and ice caps return. Apart from carbon dioxide levels, other factors that affect the Earth's temperature include plate tectonics, changes in the Earth's orbit, and variations in ocean currents. Our Earth has toggled between a scorching hothouse and a frozen icehouse multiple times in the past. But now, the climate is shifting rapidly due to human activity. And the question we're left with is, what kind of Earth are we heading toward next?